Hello everyone, welcome to chapter 5 of our Java tutorial, and today I'm going to talk about data types that are available in Java. And I would like to begin with a table where you see the different primitive data types in the Java programming language. Some of these data types we have used already. So we have used int, for example, for variables of type int to represent integer numbers. And what you can see here is that this data type int, for that 32 bits are allocated, reserved in the memory of your computer. With that you can already represent rather large integers. However, if you want to present very large integers, that might not be sufficient, and then you should use long. Yeah, so long is the data type to represent integers with more than 32 bits, so 64 bits. There you can then use larger values as well. If you're just needing integers with 16 bits or 8 bits, you could use also data types byte or short in your example, in your code. Well, in our examples so far, we also had decimal numbers like 2.5, something like that. And for that we used in our examples the data type double, which stands for double precision floating point number. So for one variable of type double, 64 bits are reserved in the memory of your computer, meaning with that you can already represent very large numbers or very small numbers or numbers with a very high precision. Well, and if you don't need that precision, you can also use the data type float. So for that, that's also like a decimal number, 3.14, for example, and there only 32 bits are allocated, meaning large numbers you might not be able to represent, or you might not be to represent numbers with a very high precision. What else do we have? I haven't talked yet about char. That's basically one character of text, yeah, so maybe A or B or C, something like that. We use multiple characters, of course, to build strings. Char could also be a symbol like plus or the question mark or the quotation mark or something like this. And to represent one variable of type char, 16 bits are reserved in the memory of the computer. Then, most importantly, we have also the data type Boolean. And that is used in Java to represent states that can be true or false. So this basically used as a logical variable. So that means only one bit in your computer. Yeah? So 0 or 1. So it's a binary number with only one position, and this position can be 0 or 1. That is just one bit. Well, these are the primitive data types, and I'm using the char data type here in this example. So what we do here, well, that is the declaration of the variable that you've seen before. Here it's a variable with name C1 and with data type char. And then you see also the initialization in the same line of code. Here I'm initializing this variable as symbol A. So we use these quotation marks here to show that this is a character symbol. Yeah? So the character symbol is placed within these quotation marks. Otherwise, if you would leave this out, these quotation marks, it would occur like a variable A. Yeah? But these quotation marks, they clarify, okay, I mean this character A here, and that character A should be assigned into this variable C1. We can also use something like this. Char C2 is equal to 97. Well, it's hard to understand what is happening here. So 97 is just the number representing A in Unicode. So in the Unicode alphabet, all these characters, they have also numbers associated with them, and 97 is just representing the A. So basically, if we now call system out println for C1 and for C2, we will get twice the same output, namely like this, A, and in the second line A as well. Okay, so another example, again, is char with Unicode characters. So what we do here is that we would like to introduce line breaks or tabs in our text. And for a line break or a tab, there exists also one character value associated with this. And to represent the line break, we use this \n, and to represent the tabulator, we use \t. So with that, if we now output these 4 char variables, what is happening? Well, first of all, we output C1, that is just A. Then we output C2, that is the line break. So with that, we make a new line. Then with C3, we make a tabulator, so that's a shift to the right. And with C1, we then output C1 again, which is A, of course. And then we get this output. A, new line, shift to the right, A again. I should point out that here we are using not the println method, but instead the print method. So the difference is that println always introduces a line break after the output. But with print, you basically just make the output without ending the line. So here I'm using this special character \n to represent the line break. But outputting this has then the same effect as calling println. So that is the difference. With print, we can simply print character after character without ending the line. With println, we make one output, and the next output will be in the line below. Okay, then I have an example with Boolean here on my slide. So as I said, Boolean values, true or false, are represented in these variables. So for example, again, it's my static void main method. I'm declaring a variable b1 of type Boolean, and I'm initializing this variable with value false. And the second one here, I'm calling b2. It's also of type Boolean, but I'm initializing this with value true. You can also see this is highlighted blue, meaning false and true. These are reserved keywords in the Java programming language. Here I'm then using the system out println method to output first b1 and afterwards b2. And accordingly, here on my command window, I see false, true, each in one line. Well, of course, with double, int, long, float, we can do mathematical computations. There are these mathematical operators like plus or minus, but we cannot do that with Boolean. Yeah? So it's not defined. We cannot add false plus true. So therefore, if we are trying anything like this, Boolean b1 and Boolean b2, and now we are trying to compute the sum of both, then our compiler will report an error. So let's read this error message again. It's saying there's an error in file mybooleantest.java in line number 5, namely error bad operand types for binary operator plus. Yes, so this plus is a binary operator which is not applicable for Booleans. First type Boolean, second type Boolean, okay, that has been recognized by the compiler, and the compiler now complains, no, this is not allowed. You cannot add Boolean variables. So what we can do instead, however, is, of course, we can take this empty string. So the parenthesis without anything in between, that's an empty string. And now to this empty string we can concatenate the value of B1. And then we can concatenate to that the value of B2. So that's understood by the compiler not as a mathematical calculation, but rather as a concatenation of strings. And that works. So if we compile and run that program now, we get this output, false, true. So that is working. So of course this plus symbol here, that is always, depending on the context, it has different meanings. Here it's a concatenation of strings. In other examples is the mathematical operator plus. Now, sometimes we have data maybe read as integer numbers, but now we would like to add an integer number to a double number or something like that. And for such operations, we need to convert between different types. So that is, of course, necessary. We need that flexibility quite often. Think of maybe you have some program which is multiplying decimal numbers. These are represented as double numbers. And now you would have to, you have integer numbers which you would like to provide to that program. Of course, that should somehow be able to deal with the integer numbers as well. And for that you need to type conversion. Well, int is implicitly converted without any command to double. So that is actually working very nicely. Let's assume you have a variable I of type int. It's initialized with value 10. Now we have a double variable d that is declared here. And now I'm initializing this double variable with value, well, with the value that is currently in my variable I, namely 10. So you're seeing on the right-hand side of this equation symbol, there's actually an int variable. And the value of this int variable is assigned to the double variable. But that's working without any problem. So the compilation works. So now, of course, if I print now the value within my variable d, I get this output, so there is 10.0. So the integer number 10 becomes the double number 10.0 without me as a programmer requiring anything to do about that. However, the other way around, that's not allowed, not possible. Well, suppose you have a double variable d, it's initialized with value 10.0. Now I'm trying to read that variable out and assign the value to an int variable I. That's not working. I mean, in this example, I would say, okay, let's actually maybe overly strict here. Why doesn't the program accept this 10.0? And this could be easily converted into an integer number. But Java is strict here. Suppose you would have a value 10.5. And now you're doing this assignment. Int I is equal to 10.5. So what should happen actually? Maybe should you round up or down? So this is not implicitly done. And therefore, if you compile this code, you will get an error message. So the Java compiler is saying error, incompatible types, possible lossy conversion from double to int. Lossy conversion meaning you would lose the precision here that is in the decimal numbers of your double variable. And this, no, I'm not doing that. That's what the compiler is saying here. I don't accept that. If you want anything like this, you should tell me explicitly what I should do. That's basically what the compiler is reporting here. So meaning here, it's our job to decide what to do with this double variable. And that is actually here what you can see here, that's an explicit type conversion. So on the right hand side, I have my variable d. And now I'm using this expression. So that's round brackets, and within these round brackets, the name of the data type, int, into which I would like to convert my variable d. And now with this explicit type conversion, the compiler also accepts this. So I, as a programmer, have taken care of this conversion. So now the compiler is accepting this code and compiling it. And what is happening is then basically that the decimal places of your double number are simply discarded. So if you have 10.7, then with this explicit type conversion, that's becoming 10. So here you can see that quite clearly now. I have a double number, 10.9999999 and so on maybe. And now with this explicit type conversion, which is also called casting, I'm casting this double number to int. So that is with this operator here. Well, and as I said, these numbers, the digits after the comma are simply discarded, so the result is simply integer 10. And that is what is then assigned into this variable I of type int, and what is then output here to my console. That is what you see here then, the 10. Well, that is working without error, without exception. However, maybe that's not what you want. Maybe you want to do some rounding. Of course, it's much closer from this 10.999999 to round up to 11. And if you want to do that, what you can do then, you use of this class math, you use the method round, and that is now actually rounding to the nearest integer number, in this case to 11, which is then the output here that I'm receiving on my console. Yeah, so with the method round, we can round double numbers to integer, or actually to long, I should say. Yeah, so the double number can be very large. So if you round that down, int would not be sufficient to represent these very large double numbers. Therefore, I'm using this long data type here, representing large integers. Okay, that's it basically concerning, well, data types and how to deal with them, how to convert with them. We've seen that in some cases this is happening implicitly without the programmer being required to do anything about that. But in some cases, like converting from double to int, the programmer has to decide whether a casting is sufficient, or maybe we want to do a more precise rounding to the nearest integer number. Then you need the round method from the math class. Well, so far about data types. Thank you very much, and see you for the next chapter.